Hello. Okay. Now, now I'm going to discuss about the chapter of class 11 physics, system of particles at rotational motion. So here the first question is, what do you mean by a particle, a system, and internal and external forces? These are the four terms which will be helpful to understanding this chapter. So, what is particle? A particle is defined as an object whose mass is finite but whose size and internal structure can be neglected. So that means a particle is defined as an object whose mass is finite but whose size and internal structure can be neglected. Which has a mass but size is very small, negligible. That is called particle. A system. A system is a collection of very large number of particles which mutually interact with one another. A system is a collection of very large number of particles which mutually interact with one another. Example, a body of finite size can be regarded as a system because it is composed of large number of particles interacting with one another. That means a body of finite size, as large body, can be regarded as a system because it has large number of particles. It is made up of very much, very many particles. Internal forces. The mutual forces exerted by the particle on a system on another are called internal forces. The mutual forces exerted by a particle of a system on another are called internal forces. That means if a system is isolated, that means it is not interacting with the outsider forces, but it is interacting among the particles of the system, then that kind of force is called internal force. That means let us consider three particles interacting with one another, but no other force is acting on that three particles. Then the interaction between one another is called internal forces of the system of three particles. Likewise, we can take many particles which is isolated from the outside and it is interacting among themselves, and that kind of forces we can call as internal forces. The forces are responsible for holding together the particles as a single object. So internal forces is the only forces which is holding all the particles together in a rigid body. That means in a large body. External forces. The outsider forces exerted on an object by any external agency is called an external forces, such forces changes the velocity of an object. That means a body made up of large number of particles. If any external agency, any outsider any outsider external agency, if that external agency apply a force on that particle, on that object, then that force is called external force, and this external force is only responsible for the changes of the velocity of the object, but internal forces cannot change the velocity of the object, but external forces can change the velocity of the motion of the object. Now let us come to a new term which is center of mass. What do you mean by a center of mass of a system, and how does it differ from center of gravity? This is a question. So let us discuss about center of mass. Newton's law of motion are applicable to point object, and the introduction to the concept of center of mass enables us to apply them equally well to the motion of finite or extended objects. The center of mass of a body is a point where the whole mass of the body is supposed to be concentrated for describing its translatory motion. The center of mass of a system of particles is that single point which moves in the same way in which a single particle having the total mass of the system and acted upon by the same external forces would move. That means if we consider a a point on the object is a center of mass, then we can apply Newton's law of motion on the object by considering the whole mass of the body is considered concentrated on that point, and if we apply external forces on that point on that object, then that point will move according to the law of Newton's law of motion. So that point we can call as a center of mass. So you can look at concept of center of mass. You can look at the hammer, a picture of an hammer. So it has a larger height, that is handle's head, and you can and another is arm of the hammer, and this handle head has larger mass, so the center of mass will be inside that hammer's head, and if it moves, it can rotate, it can translate from one point to another. Also, it can rotate about this center of mass. So now let us look at center of mass versus center of gravity. The center of mass of a body is a point where whole mass of the body may be assumed to be concentrated for describing its translatory motion. So we know that center of mass is a point where whole mass of the body is can be supposed to be concentrated on that point. And if the object moves, then the center of mass translates from one point to another point. And center of gravity is the point where all the forces of gravity may be supposed to act at on that point. On the other hand, the center of gravity is a point at which the resultant of gravitational forces of all the particles of the body acts. That is a point where whole weight may be assumed to be act in a uniform gravitational field such as that of the Earth on a small body. The center of gravity coincides with the center of mass. But in case of Mount Everest, the center of gravity lies a little below its center of mass because the gravitational force decreases with altitude. Okay, so uh, so center of gravity is a point where whole weight, whole weight, that means gravitational forces act may be supposed to be acted on that point of that point is called center of gravity. If the object is if the gravitational field, that means force of gravity, is equal in all the point and all the places, then there's for any object center of gravity will lie at the center of gravity, center of mass of the object. But for a larger body like Mount Everest, the center of gravity is just below the point of center of mass of the mountain, because the gravitational force of that is the force of gravity, that means acceleration due to gravity, uh, changes with altitude. That means if we go move higher, uh, then the acceleration due to gravity will decreases. So the gravitational force will not act it same way in all the places of that Mount Everest. So its center of gravity lies just below the center of gravity of the mountain, center of mass of the mountain. Now let us look at center of mass of two particle system. So here you can say that the center of mass of two particle system we have taken. We consider an two particle we consider two particles m1 p1 and p2, which is having m1 and m2 masses, and it is measured in x-ray plane. From the origin, P1 is lying at the position R1 vector and P2 is lying at the position R2 vector. And we can consider any point between these two particles, between the line joining between two particles, uh, is C, uh, which is having at a position R CM vector from the origin. So center of mass of a two particle system. Consider a system of two particles P1 and P2 of masses m1 and m2. Let R1 and R2 be their position vectors with respect to the origin, as shown in figure 7.2. You can see that picture. The position vector RCM of the center of mass C of the two particle system is given by so center of mass RCM vector, position vector RCM of the center of mass C of the two particle system, maybe a system is given by RCM is equal to m1 multiplied by r1 vector plus m2 multiplied by r2 vectors, whole divided by m1 plus m2, which is nothing but the position vector of the center of mass of the two particle system. Discussion. The above equation shows that the position vector of a system of particles is the weighted average of the position vector of the particle making the system, each particle making contribution proportional to its mass. So we can say that the weighted average of positions of the particles making the system. So you can say this is a weighted average, weighted average of the position vector of the particle in the system. And now we can consider some cases. Number 2, we can write the above equation as the above equation simplify as m1 plus m2 multiplied by r cm vector is equal to m1 r1 vector plus m2 r2 vector. Thus, the product of total mass of the system and position vector of its center of mass is equal to the sum of the product of individual masses and their respective position vectors. Number 3, if m1 is equal to m2 is equal to m, say if the two particle of is of equal masses, then our center of mass RCM will be m1 plus r1 vector plus r2 vector divided by 2. Thus, the center of mass of two equal masses lies exactly at the center of the line joining the two particle masses. So, if the center of if the two particles is of equal masses making the system, then the center of mass will lie at the centers of line joining the two objects, exactly at the center of the line joining the two masses. If x1 y1 plus and x2 y2 are the coordinates of the locations of the two particles, then the coordinates of their center of mass is given by. Now let us take two particles. P1 particle is at position x1 y1 and P2 particles is at x2 y2. Then corresponding position of the center of mass along x and y axis is given by xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2 ycm is equal to m1 y1 plus m2 y m1 y1 plus m2 y2 divided by m1 plus m2. So these were the discussions about center of mass and few terms regarding system of particles and rotational motion chapter. Thank you.